Hi everyone, hope everyone's doing well. I'm Siri, and in this video we're going to be covering the formal definition of a limit. In our last couple of videos we touched on the more intuitive definition of a limit, but now we're actually going to get into the Epsilon-Delta definition, which we've talked about, which we've mentioned in a previous video, but we haven't really dug into that, right? So that's what we're going to do in this video. So first of all, this is a common definition that you'll come across in any calculus class, and it's the delta epsilon definition. And so first, let's review what it means to be a limit, right? When we, as the closer we get to that x value of interest, the closer the y value gets to a particular value if the limit exists, and that value is the limit if it exists. And so let's formalize this idea of getting closer and approaching a certain value for both our inputs and our outputs, right? So we can say that let's start off a little bit more abstract, but then we can get into a more intuitive example that sort of like demonstrates this idea either at the end of this video or in our next video, okay? But we've established the idea that as x approaches a value, the y value will also approach a value if the limit exists. And so what does that exactly mean? What that means is that if x gets really close to a value, let's call it a, if x gets really close to a, let's write a little neater, if x gets really close to a value a, right? If x gets really close to a value a, then what happens? Then our f of x also gets close to a value, right? Our f of x gets close to the value L, okay? And so what do we mean when x approaches a? When x gets really close to a, well, that means that the difference between x and a is going to be very small, right? So let's say that x minus a is very, very small as our x value gets really, really close to a, which is our point of interest, right? And so that's very small, as well as the difference between our f of x and L, right? That's also going to be very small. And so this is going to be small, well, rather, this is going to be small when this is very small, right? When these both values are very small, then we say that we've approached a value, we've taken the limit of f of x as x approaches a. And so let's call these differences. We're actually going to take the absolute value, and the reason why we're going to take the absolute value to represent this difference is because we don't care whether a is the value that's approaching a, right, the value that's very close to a, our x value, is either a little bigger than a or a little smaller than a. It doesn't matter to us. All that matters to us is that it's just a little bit further away. It doesn't matter in which direction. So therefore we are taking the absolute value because we don't care about whether it's lower, whether the difference is positive or negative. Okay, so we're going to take the absolute value, and these differences are not going to be the same, right? When we're approaching x, that difference is not going to be the same as the difference between f of x and L, because it's the input and the output. They're two different values, right? And so because they approach their own respective input and output values, we're gonna have different letters to represent both of them. So let's say that our x minus a is delta, and our f of x minus L, the absolute value, is epsilon. So that's where the delta and epsilon sort of definition. So it's actually the delta epsilon definition. Right, so let's restrict our x minus a to a delta, right, and our f of x minus L to epsilon. Okay, this is an epsilon. Okay, and so let's have some conditions just to make it more, just for like convention, right? So there are a couple of things, three things. X minus a, let's say that difference is always positive, right? We're taking the absolute value and we're not gonna be a negative distance away, right? So let's keep that consistent, let's keep that convention. Let's also make sure that epsilon is greater than 0. Same, f of x minus L. And similarly, this, actually 1 and 3 are the same. Our delta is going to be greater than 0. Okay, and so basically the formal definition of a limit is simply the fact that this x minus a, if x minus a is less than a certain delta value, then that implies that f of x minus L, this absolute value, is less than an epsilon. And once again, these values are different because we're approaching a different input value, and the input value and the output value are different, and the starting values are also different. The value that is approaching the point of interest in both x and y. So yeah, so that's basically it. We're just like introducing a more formal way to describe the word approach is basically it. And really that's all I wanted to cover in this video. I know it's a little short, but we've gone over the theory of what the formal definition of a limit is and introduced a couple of variable names, and yeah, I think that's about it. Thank you so much for watching, and I hope you learned something new, and I'll see you in my next video. Bye.